Hello and welcome to the next video for Virtual Lab Practical Hope. In this video, we are going to plot the probability of various macrostates versus number of heads in coin tossing experiment. Coin tossing is an important random experiment in statistical mechanics, throwing light on the fact that disorder is simply vastly more likely than order. Consider the case of 4 coins. What are the possible outcomes of tossing 4 coins? Each coin can either land heads or tails. The following possibilities exist. They can be 4 heads, 0 tails, 3 heads, 1 tails, 2 heads, 2 tails, 1 heads, 3 tails, and 0 heads, 4 tails. These are macrostates as they do not specify the details of the system, such as the order in which heads and tails occur or which coins are heads or tails. If we take into account the order in which heads and tails occur, each sequence is called a microstate. A detailed description of every macrostate. These are the possible macrostates since we are considering the case of 4 coins, so number of macrostates will be 4 plus 1, that is 5. In first case, there is only one possibility of arranging 4 heads, so there will be only one microstate. In second case, there are 4 possible ways of getting 3 heads and 1 tails as shown. Third case will have maximum number of microstates as shown. Similarly, there will be 4 microstates for 1 heads and 3 tails, and finally there is only one microstate for all 4 tails. Total number of microstates 16 is given by 2 raised to the power 4. 2 represents the number of possibilities, heads or tails. 4 represents the number of coins. Now we can easily calculate the probability of particular macrostate. In first case, it will be 1 by 16, that is 0.0625. In second case, probability is 4 by 16, that is 0.25, and so on for the rest of the cases. Number of microstates associated with a particular macrostate can also be calculated mathematically. Suppose we consider the third case. Number of microstates for 2 heads and 2 tails are 6, given by 4C2, since we have to choose 2 heads from 4 coin tossings. The 2 most structured possibilities are 4 heads or 4 tails. They are also least likely, only 1 out of 16 possibilities. The most disorderly possibility is 6 out of 16 for 2 heads and 2 tails. So in general, if we have n number of coins, then the total number of microstates will be 2 raised to the power n. Number of microstates associated with a particular macrostate, say p heads, is given by NCP, that is n combination p. Let's move on to the programming part now. First, write the title, plot the probability of macrostates in coin tossing experiment. Clear is to remove the variables in the workspace, CLC is to clear the console, and SCILAB will clear or reset the graphic window to default values. Small n represents the number of coins and is an input parameter. Total number of microstates, NOM, is given by 2 raised to the power n. Next, there will be a for loop, since we have to calculate the probability for all n plus 1 macrostates. J represents the number of heads that will vary from 0 to n. Number of microstates for a particular macrostate can be evaluated using the formula as shown in the figure. Probability can be evaluated by dividing number of microstates for a particular macrostate ns with the total number of microstates nom. P is a vector having probability values for all possible values of heads. We also need to store all the possible values of heads in different macrostates. Here H represents the vector with all possible values of heads. Now we can display different probability values for different possible values of heads. Run the program, enter number of coins, say 4. So we have got the probabilities for different heads. We can also display heading for heads and their probabilities as shown in the video. Run the program again. Enter 4. Now we'll plot the result using plot function. O minus will display the points on the graph along with the curve. Set line width 4. Give a suitable title denoting the number of coins. We can also set X and Y labels with font size 6 as shown in the video. Again run the program. Enter number of coins. So this is the plot of probability with number of heads for 4 coins. We want to perform the experiment with different number of coins and plot the results simultaneously. So first we have to define an input variable capital N representing number of times experiment need to be performed. We have to set another for loop that will vary from 1 to capital N. Now all these selected statements should be under for loop. So cut them and paste here. Finally, we have to use subplot function to separate all the plots. Now the graphical window will be divided into 1 row and n columns, and I represent the position of the subsequent plot. Run the program. Enter number of coins, say 4, 8 and 16. So we have got the probability values. These are the corresponding plots. If you like this video, share it with your friends and colleagues, and don't forget to subscribe our channel if you haven't done it yet.